All right, so today we're going to look at two ways to represent lists of values, kind of in a compact way. The first one's called box and whiskers plots. In a lot of books, you'll see this called a box plot. Okay, and then we're also going to look at stem and leaf plots. Okay, and kind of what you need to know about them. So first, let's look at what a box and whiskers plot looks like. It's kind of a nickname, honestly, the box and whiskers. And so maybe you'll see why it's called that when you look at the shape of it. Okay, this is an example of a box and whiskers. Notice we have two boxes in the center and then we have two whiskers. Okay, the fact that the pieces are not of equal length is actually purposeful. Often you're going to find that the lengths are not equal. And so we have the minimum and the maximum value shown by the quote whiskers. Okay, and then we have Q1, Q2, and Q3, which describe the boundaries for the boxes. So what happens in a box plot or a box and whiskers plot is that your data values are split into 4 sections. Okay, 2 boxes in the middle. And a whisker on each side. And you can judge for yourself whether or not you think it looks like a whisker. I think that's kind of a goofy name for it myself, but I didn't come up with a name. Okay, so that's just what they're kind of affectionately called. Okay, so because your data values are split into 4 sections, they are going to be split equally. In other words, 25% of the data values will be in each of the 4 sections. So 25% of the data values are in each whisker. Um, 25% of the data values are also in each box. So length doesn't have anything to do with the number of data values that are in each section. Okay, in fact, there's always just 25% in each. Okay, so in other words, if we came back up here, there is 25% of data in this left whisker, there's 25% in this box, there's 25% in this box, and then finally 25% in that box. Okay. And you will see occasionally some standardized testing reported to you as a box plot. What it's supposed to indicate is, like if it were test scores or something, students in the top 25%, okay, would obviously be in this left or right little section. Okay, the bottom 25% would be down here, and those would be the students that would probably need remediation. And then your average students would be in the middle. Okay, they would be part of the 2 boxes, the 50% in the middle. All right, so a couple of things to note. The pieces will not necessarily be the same length. In fact, most of the time they will not be. But it doesn't mean they can't be. It just means most of the time you won't see that. So if they're not going to be the same length, and if each section contains the same number of values, then what does a smaller section indicate versus a bigger section? Well, in a smaller section, it just means that the data values are clustered close together. So it doesn't mean there are fewer of them, it means they are not that spread apart from each other. Okay, so they're concentrated kind of closely together. Okay, so then a larger section doesn't indicate again that there are more values because there's 25% no matter what, but the larger section indicates that the data values are more spread out. Okay, so notice this Q2 is going to be the center, right? If we're talking about 25%, 25%, so that means 50% should be below the Q2 and 50% should be roughly above the Q2. Okay, so the 5 important values that we need to be able to find to create for ourselves in a box and whiskers, we're going to need to know how to figure out 5 things. So we're going to need to know how to find the min and the max, but those are usually easy. As long as the values are listed in order, that's not so bad. And then you will need to know how to find the Q1, the Q2, and the Q3. Okay. Q1, Q2, and Q3 are what we call quartiles. That's what the Q stands for. Okay. And the quartiles just indicate the ends of each 25% section. So in other words, if you look up at our picture that I drew for you here, Q1 is like the end of the first 25%. Q2 is the end of the second 25%. Q3 is the end of the third 25%. And then finally the max is the highest value, right? The end of all the values. All right, so the handouts for this week, I want to make sure that you printed those out. So we're going to look over a few of those. Okay, we'll come back to the notes in just a minute. So I want to look at the comparison of these 3 Little League teams. Okay, now notice they drew these box and whiskers vertically. They don't have to be horizontally like we showed them before. Okay, so notice for all the teams, the lowest batting average player is a .100. Okay, and the highest batting average player is the .400. And all of the rest of the teammates are in between those batting averages. Okay, so notice in all 3, right, the lowest batter is here, the highest batter is here, but how the middle is spread out is significant. Okay, so let's kind of label this. This would be the bottom 25% of batters. This would be the middle 225s, right? So that'd be the middle 50. And then this would be the top 25%. Okay, notice 25% of the team. So let's just say there were 20 members on the team. This would be roughly the top 5 players, right? If there were 20 members on a team, you divide that by 4. So notice, it doesn't mean that there are more players in here, okay, where I'm pointing. It just means that their batting averages are kind of wildly different, right? Even in the top 25%, you might get one with a .400 batting average, but you might get one that's even probably less than .2. Okay, so the length of this just indicates that the values are kind of unpredictable. They're kind of way spread out from each other. Okay, so let's look at team number B. So I know it might be hard to see from your copy, but we do have 2 boxes here. Okay, so if you need help on seeing where those lines are, this one's about right here, this one's about right here, and this one's about right here. Okay, that's the line separating the boxes. Okay. So notice here, we're a little more predictable on our top 25%, right? Like the top 25%, it looks like maybe bat like a .300 or higher. Okay, so that's a little probably more consistent and dependable than this team, right? Notice the second 25%, if we're going from highest batting averages to lower, are very clustered close together. In other words, these players are really consistent. They're really close in batting average to each other, okay? And then notice we have a really big section here. Okay, again, that doesn't indicate that we have more players. It just indicates that the values are more spread out. And then, of course, we got the bottom 25%. So same thing here, right? 25% for each section. Okay, so notice we're really predictable on the top, right? Where we are not predictable is down here, but notice even their lowest 25%, there's still some of these guys that have a decent batting average, right? So this, if you answered the question, if your main concern is winning, you would want this team, right? This would be the winning team, you know, provided that defense was there, right? We're talking about just offense here, but so I like the way this is worded. If you wanted to have a challenging coaching experience, that's the politically correct way of saying maybe that the team doesn't have quite as good of the stats as the other 2 teams, right? So which team has kind of the worst stats? That would be this team, right? So we'll call this the challenge team. Okay, because notice even in the top 25%, like you might have some really lower batting averages. So the fact that this is kind of slid up just means that as a whole, if you compare section by section, this whisker is better batting averages than these 2. This top box in general is pretty much better than these 2. Okay, this one might be a little bit better for that section. This is better than these 2, right? And then this is higher also. Okay, so that's just an example of how box plots can look and how the fact of the length really just indicates the spread of values, not how many values we have. Okay, so the next one that I want to look at, I want you to pull out this worksheet. Okay, so we're going to kind of see if we can figure out if we can answer some questions. So you're not going to be turning this one in, you're just going to be working with me. Okay, so what is the median? Remember what I said, the median is, remember mean, median, and mode, the median is the middle, right? So Q2 is the middle, okay? So they're asking what Q2 is, right? And if you look at the number line, it looks like Q2 is right about at 20. Okay, and then it's going to ask you for the lower quartile. Okay, so the lower quartile is going to be Q1. So that's going to be right there, right? Q1 is the start of the first box. Okay, so notice that Q1 is at about 18. And then it says, what is the upper quartile? Well, by that they mean Q3. And notice Q3 is located at about 22. But then they also want us to figure the max and the min. I'll switch those, right? This would be the min, this would be the max. So the min is going to be 17. Okay. Careful about the max. The max is not 23. It's actually one tick mark after 23. And if you see that the whole is split up into 6 pieces, okay, then it's actually 23 plus a little small section. And since there are 6 of them, that would be an extra 1/6. So the above 5 values, honestly, really just the Q values are called quartiles, but in some texts, they call all 5 significant values quartiles. Okay, and by 5, I mean the min, the max, Q1, Q2, Q3. Okay. What is the range of data? So remember, the range is just the highest minus the lowest. So you just need to look at your max and your min, right? So if you take 23 and 1/6 and you subtract off 17, you're going to get a difference of 6 and a 1/6. Okay. All right, so let's slide this back. Okay, so what percentage of data is below the upper quartile? So here's the upper quartile. Okay, so what percentage of data would be below that? Well, let's figure that out. Each of the 3 sections would have 25% in them, right? So the percentage of data that is below the upper quartile would be 75%. Okay, what about the percentage of data that's between the lower quartile and the median? Let me slide that back up. Lower quartile, this is the middle or the median, right? So how much is in between these? Well, that's only one section, right? So that would be what? 25%. And then last but not least, I won't even slide the picture for this one. What percentage of data is above the median? Okay, well, it'd actually be the same answer as what percentage of data is below the median, okay? But the percentage of data that would be above the middle would be half. Okay, same with below if I would have asked you that. So what we're going to practice next is how do we go from data values to drawing our own box plot, our own box and whisker plot. Okay. By the way, this is a great source for you if you ever teach math. Okay. Mathworksheetsland.com. There's all kinds of free sources out there. Okay. There's paid sources out there too, but I always try to find kind of free worksheets. So I left that on there so you could kind of look on there and kind of see what you think about that site. Okay, so I want to walk you through kind of how we're going to create a box and whiskers plot. So we're going to use this, but honestly, then I'm going to list out the steps for you. Okay, so first you're going to start with a set of values. Okay, notice we have 12 values here. Okay, so the first thing you're going to do is you're going to draw a horizontal number line that represents the range of your data. So notice we started at 1 and we ended at 16 because that's the range of our values, right? We go from 1 to 16. Okay, so the first thing I would like you to practice is just plotting the points. And we're going to use what we call a dot plot for that. So notice if we have multiple values, we stack them. So since I had 3 5s, I'm going to stack it like that. I had an 8, a 9, a 10, a 12, 2 15s, so I'll stack those, and then a 16. Okay, so notice a pretty good spread of our data, right? Notice in certain places the points are kind of clustered or close together, and then in other places they're kind of spread out. Okay, so it just kind of depends on what part you're looking at. Okay. All right, so let's go through. So first it says draw a vertical line at the median of your data. Okay, so the first thing we're always going to find is what is Q2. Okay, Q2 is always just the median of the data as a whole. Okay, so if you have 12 values, you're going to have 1, 2, 3, 4, 5, 6, 7. These are going to be your median. Okay, so not Q1, that would be Q2. Q2 is going to be the average of these. Okay, you can either show the work there, or you can just think about what would be square in between 8 and 9, and that would be 8.5. Okay, so notice they're kind of doing it in stages, but we're going to do it together. So we're going to draw a vertical line at 8.5. Okay, because that's our Q2, and we're going to label this as Q2. Okay, so how do you find Q1 and Q3? Well, for that, you're going to split the data into halves. Okay, so notice it says draw a vertical line at the lower quartile of your data, the lower quarter. Okay, so in other words, if I split the data in half, okay, I need to find the median of the first half. Okay, so the median of the first half. So the first half is just 1 through 8, right? So the median of the first half is going to be what would be in between 5 and 5. I don't really need to average that to make that work, right? That would just be 5. Well, that's my Q1. Okay, so we're going to draw another line at Q1. And then we're going to do the same for the upper half. Okay, so the median of the second half. Okay, so notice, make sure you include 9, right? The second half is 9 through 16. Okay, so the middle would be in between, let's see, 12 and 15. So if you need to, we can go ahead and average those. So 12 plus 15 divided by 2 would be 13.5. Notice 13.5 is right in between 12 and 15 though. So here I'm going to draw another line, okay, and this is going to be my Q3. Well, notice now I have 3 lines, right? So now I'm just going to connect those to form boxes. And then as far as the whiskers go, they're actually pretty easy. You just put a line here. Sometimes in some books you'll see a dot instead, and then you'll put a line at the max and kind of connect it. So this would be my min, and this would be my max. Okay, and notice if I didn't have kind of all this messiness and I had a little more room, notice I have the 5 significant values marked, right? The min, the Q1, the Q2, the Q3, and the max. Okay. I'd also like you to notice that since we had 12 values, if we were to split 12 values into 4 sections, we should roughly have 3 values in each section. Notice it gets a little weird here, right? Because we have so many values kind of on the line between the first section and the second section. But roughly, if you consider these kind of together, notice there are 6 values to the left of Q2, and there are 6 values to the right of Q2 since Q2 is the center. Okay. Notice there's about 3 values here, about 3 values here. The first 2 sections are a little weird again because we have so many points here. Okay, so notice the more clustered the data is, notice this is the smallest section, right? And it doesn't mean there are less points. There's actually 3 points just like there are in this one, but these 3 are more spread out than these 3. These 3 are clustered close together, which indicates you'll get a smaller section, okay, a smaller length section. All right, so notice this just basically did all the things that we did and just kind of did it a piece at a time. Here it drew 1 line. Here it drew the lower quartile, upper quartile, connected them to form boxes. Okay, so it just kind of did everything that we kind of did together there. Okay. All right, so what if you don't have a guideline like that worksheet? So I want you to be able to create meaningful box and whiskers plots. So the first thing you're going to do is you're going to plot all the values on a number line. And just to remind you, this is called a dot plot. Okay, step number 2 is you're going to find the median of all the data. And this will be your Q2. Okay, so we find the middle one first, actually. Okay, and then you're going to draw a vertical line for the boxes here. Remember, Q2 is going to be the middle line between both the middle boxes. Okay, step number 3 is then you're going to find the median of the first half of the data. This is Q1. Okay, so the median of the first half of the data is Q1, and then you're going to find the same for the second half of the data, and that's going to be Q3. So just kind of a quick reminder, remember for any kind of median we have to have the numbers be in order. So in your homework that's kind of a consideration, so make sure that your values are in order. Sorry, I didn't mean to call that Q2, I meant to call that Q3, sorry. We already found Q2. And then you're going to draw lines for Q1 and Q3. And lastly, you're going to complete the drawing of the boxes. And you're going to use the min and the max for the whiskers. So just so you know, box plots are something used in kind of upper level stats classes, but we teach this topic actually in junior high. So in junior high, we definitely call it a box and whiskers plot. Okay, and as you get older and take statistics classes that are, you know, a little more mature, then they don't call them box and whiskers. They call them box plots instead, typically. Okay, but you're going to need to be familiar with both terminologies because you're probably going to see both. All right, so let's do 2 box plots. If you'll pay attention to how these two are a little bit different from each other, then you should be able to do any of the ones on the homework. So before you can draw the box and whiskers plots, first you're going to draw a number line, okay, and then you're going to start to find the significant values. So let's say this is our list of values. So you'll want to leave yourself some room, but the first thing you're going to do is just create for yourself a number line. So I'm going to go from 3 to 10. There's really no need for you to go past your low and your high because none of your values are going to extend past that. So the first thing I would want you to do is graph those. Okay, so notice we have a 3, we have a 5, whoops, not that one. Okay, so don't include that one. We have 2 7s, we have an 8, a 9, and a 10. Alright, so now we're going to find the values of significance. So the min and the max are no big deal, right? But do list them in order if they're not in order, but these are. Okay, so the min is 3 and the max is 10. Okay, so now we just need to do some work to figure out what Q1, Q2, and Q3 are, and then we'll be there, right? This really isn't that long of a process once you practice it. Alright, so first let's find Q2. Now notice, unlike the problem we just did together, the median is just a single number in this problem. Okay, so if there's an odd number of points, there's no tie for the middle. Okay, then you just circle the middle number, and that's going to be Q2. Okay, and so we're going to indicate that 7 is our Q2 by drawing a box, or at least a line for a box. I usually draw it kind of suspended above the number line. I don't actually bring it all the way down to the bottom. Alright, so notice we have one single median, so it really wouldn't be, quote, fair to include that median in either half. So just so you know, when there's an odd number of data points, the middle's not going to be included either in the first half or the second half. But if there's a tie for the middle, you'll split them, right? You'll send one to the left and one to the right, okay? Alright, so what would be the median of the first half if 3, 5, and 7 is the first half? It would just be 5, right? So this is going to be your Q1. And then same thing with the second half. Notice the second half is just 8, 9, and 10, so the middle of that would be 9. And so what we're going to do is at 5, we're going to put a vertical line, and also at 9. And then you can draw your boxes. And then you just include your whiskers, right? The bottom whisker ends at 3, or starts at 3, I guess, and the last whisker ends at 10. Okay? In the end, I do want you to label these. So this would be the min. This would be Q1. This would be Q2, Q3, and the max. Okay, you can even label them with numbers if you want to, but I think that's good enough. Now notice, here we had 7 values. So if you tried to split up 7 values into 4 sections, you couldn't do it equally, right? So you'd have roughly 2 points in every section. So remember, that was a mistake of mine, right? But notice, every section has about 2 points. Okay, again, this one's kind of like the last one. We have a lot of points on the boundary lines between sections, but in general, we have about 2-ish points per section. Okay. Okay, so let's look at one. I want you to try this one. So I want you to pause the video once I list you out the points, and I want you to see if you can do it. So try to draw the box and whiskers plot. You'll want to use pencil on this. I know I'm using pen, but obviously I just made a mistake there, right? So let's say that I was given this list of numbers. Okay, so pause the video and see if you can do it. Start off with a dot plot and then see if you can figure the 5 significant values: the min, the max, the Q1, the Q2, the Q3. Okay, so for this one, I'm going to start counting at 5. I'm going to count all the way up to 10. Okay. Oh, I need to go further, right? So I actually need to go to 12. Okay, so let's graph them first. I have a 5, I have 2 6s, I have an 8, I have a 9, a 10, an 11, and a 12. Okay, so I say the min and the max are pretty easy to find, right? As long as they're in order, it's just going to be the first one and the second one, or the first one and the last one, I mean. But now let's see if we can find the different Q values, right? Notice in this case, I am tied for the middle. Okay, so if I want my Q2, I'm going to have to go square in the middle of those, so that would be 8.5. I don't know why I wrote 8.9. 8.5. Okay, so what I'm going to do down here on my number line, just so I'm pretty exact, is I'm not only going to mark 8.5 with a bar, but I'm actually going to number what it is. Okay, I'm going to actually indicate that on my number line. Okay, so that I'm clear. So that's going to be my Q2. My Q2 is 8.5. Okay, so now when I try to go and do the halves, remember that actually if you have 2 medians, okay, then you split it this way, right? This is the first half, and this is the second half. So if you have 2 medians, just send the one on the left in the first half and send the one on the left to the second half. Okay, so notice I have 4 numbers in the first half, right? So I would want to go halfway in between. Okay, so if you average 2 6s, you're going to get another 6, right? So this is just going to be 6. So when I go to graph this, I don't have to mark something new, right? Because 6 is already shown on my number line. And then last but not least, and then let's see if we can draw this, the middle of the second half, right? So let's cover up the first half. So the middle of 9, 10, 11, 12 would be 10 and 11. But you would need to find the average of those, so that would be 10 and a half. Okay, so here I'm going to mark 10.5 before I draw my line. So here are my boxes. And then here is my whiskers. Okay, and then again, I want you to mark these. So this is going to be Q1, Q2, Q3, and the max. So on your homework, your number line should indicate all of the values. It should be very clear. So if you have to go in between two whole numbers, then make sure you indicate that. Okay. All right, so make sure you pay attention to the difference between these, right? When there's a single Q2 or a single median, you don't include that in either half. When there are two medians, you split them up and one goes to the left and one goes to the right. All right, so I think that'll pretty much get you where you need to go with your homework. Just make sure your number lines are appropriate. Sometimes I'll, for instance, count by fives or something, but make sure that you're very clear on what you have. Okay. All right, so the second type of graph that we're going to, or not really graph, but more like a way to represent your data, is called a stem and leaf plot. And this may look weird, but actually this is a great way to represent data, especially data that is lengthy, in other words, lots of values, or data that is real clustered close together. So in this case, it's going to be kind of a table where the data is split up by digits. So this is an example of a stem and leaf plot. So it looks kind of like an XY table from algebra, okay, but it's not anything like that. And so let's say I had stems that were 0, 1, 2, and 3. Okay, so when I say the data is split up by digits, often this is going to be what we call the tens place. And then this is just going to be the ones place. And so you might see a list of values here out to the side of each stem. Okay, sometimes they'll be separated with commas and sometimes they won't. But this would represent the ones place. Okay, so before I talk about what values this is representing, it basically splits values by place value, but the leaf column should always be single digit. Okay, the leaves are always single digit. Okay, so basically you read this, think about it like a tree, right? You have stems that have multiple leaves coming off of it, so that's kind of what it is. So it's like 0, 5, 0, 6, okay? This is 1, 0, 1, 5, okay? So this represents the specific values of 0, 5 would be 5, 0, 6 would be 6, 1, 0 would be the number 10, 1, 5 would be 15, maybe you get the hang of it now, 18, 2, 3 would be 23, 3, 1, and 3, 3. Okay, again, sometimes you'll see stem and leaf plots where there are no commas, where you just list digits. Okay, so you need to be aware that, you know, different books are going to list them different ways. So this is best used when the data values are many and heavily clustered. Okay, so let's look at let's create a stem and leaf plot for the following list. Okay, so this is going to be kind of a longer list because, again, that's really what we use stem and leaf plots for, is lengthier lists or lots of data values. If these are not in order, like I'm giving them to you in order, If they're not given to you in order, you do need to put these in order as well. Okay, so this time we're not going to use commas in between just because I want you to get used to both. Okay, so notice, what goes in the leaf column is always the last digit, right? What goes in the stem column is the tens place. Okay, so notice, we only have numbers that are from 2 to 30, right? In other words, numbers where the first digit is 0 versus numbers where the first digit is 3. So if you list the things under 10, you'll have a 2, a 5, and a 7. Okay, when you get to the things that start with a 1, okay, then you just write the last digit here. So 5, 6, 6, 6. Notice if I have duplicates, I'm including those, right? And then I have an 18, and then I go on to the 20s, right? There's a 21, 24, and 25. And then last but not least, we have 4 30s. Okay, so it's important to note that you do need to include duplicate values. Okay, also notice if I wanted to get a count, like if I was given the information in this format, then I could just count how many numbers were in the leaf columns. Okay, and then that would tell me how many values overall I had. In other words, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. If I wanted to make sure I didn't forget any, I could just make sure I had 16 leaves. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, doesn't guarantee that they'll all be right, but you know, at least indicates that we won't forget any. All right, so let's do one more and then we're going to look at one of the handouts. Create a stem and leaf plot for the following data: 84, 115, 101, 124, 111, 103, 132, 145, and 142. Okay, so make sure that there are 9 values. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so notice the first thing is we really need to list these in order. Okay, you can kind of do that as you go with the table if you want. Okay, but I'm going to list them in order. So notice we have an 80, right? That's going to be our lowest number. Notice we have no 90s. We'll talk about that in a minute. Okay, we have some in the 100s, right? We have a 101, a 103. By the way, sometimes when I'm worried about forgetting some, I'll do this. Like I took care of my 84, like I'll cross them out as I go. So I have a 111, a 115. Looks like I just have one in the 120s, right? 124. Looks like I just have one in the 130s, 132. And then finally 142 and 145. Okay, so it's important to note that the leaves should always be single digits. Okay, so in other words, we're starting with the 80s, and then we're going to go ahead and include the 90s even though we don't have any. Okay, and then this would be the 110s, the 120s, the 130s, the 140s. Okay, so notice this is still the tens place, sort of. Okay, because 14 tens would be 140, right? And then let's just list all the numbers we have, right? Notice if they're in order, that makes this easy. So 84, I want you to include values that are skipped. Okay, so even though we're not going to write anything there, I'd want that there. 101, 103, 111, 115, 124, 132, 142, and 145. Okay, so you read it like 142, 145, 132, 124. You read it in that way. Okay, so make sure you include stems you skip, but notice I didn't start from 0 or anything. Since our lowest stem was 8, I can just start there. Alright, so I want you to pause the video and see if you can do this worksheet with stem and leaf plots real quick, and then we're going to go over the answers really fast. All right, so notice, hopefully you worked on this on your own. Notice how these aren't really in order, okay? So really this would be better if these were in order. But how many players scored less than 56? Notice I can talk about lots of players in a compact way, right? So here's 56, right? So I have a 53 and a 55, right? But then everything in the 40s would be less, and everything in the 30s would be less. So I've got 1, 2, 3, 4, 5, 6, 7, 8, it looks like. Okay, so 8 players scored less than 56. How many players scored less than 42? Okay, so notice less than 42 would be this 41, right? Not this, right? That'd be higher. And then any of the 30s, right? So there would be 4. Okay. What are the lowest 3 scores? Okay, the lowest 3 scores would be 32, 33, and 34. Okay. Again, notice those are a little out of order there. Okay. What are the top 2 scores? That would be in the 80s, right? So it'd be 85 and 87. Okay, what is the range of the scores? Well, how do I find range? I take the highest value, which is 87, minus the lowest value, which is 32, for a difference of 55. All right, so now let's go down to this one. How many teams were in the league? Remember what I said, you can do a count just by counting these, right? Because it's going to be 33, 38, but you can just do a count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So by counting the leaves, you tell how many values there are. How many teams played less than 52 times? Okay, so again, these may or may not be in order, but here's 52, right? None of these are below it, but all 4 of these and all 4 of these, since these are 40 numbers and these are 30, so that would be 8 or less than. How many played more than 44 times? So we have these two, 46 and 47, and then everything else, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, I won't spend too much time on this, but what is the mean number of games played? Notice you would have to take the sum of all of those, and then if you look at number 6, you would need to divide that sum by 18. So if you add them all, by the way, you don't just add these, right? You add the actual numbers, 33, 38, 36, all that. So I'll let you kind of practice that. I don't want to really talk too much about that because we've done mean already this semester. So when you work that out, you get 54.16. Actually, I think the bar is just over the 6. So I think it's 54.1 with the bar over the 6. And then how many teams played the same number of games? So you're looking for a repeat, right? So no repeats here, 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 here. Notice we have a repeat here, right? So it looks like 2 teams played 33 games. Okay, so notice that we're able to take a list of what would be kind of a boring list of 18 values, and we're allowed to kind of compactly look at them, right? So that's the benefit of the stem and leaf plot. It allows us to look at multiple data values kind of quickly, and it allows us to do it in a compact way.